James Webb Telescope just detected something bizarre on Proxima b. Something strange has been going on in the solar system closest to ours. Proxima Centauri is only 4 light-years away, and scientists have detected some unusual signs from Proxima b, one of the system's planets. These strange anomalies, dubbed artificial lights, have been rattling the space community's brightest minds. But what are they? And is the evidence of intelligent life on the planet? In this video, we'll take a look at what James Webb Space Telescope detected on Proxima b. You're not alone if you've ever wondered why humans exist only on Earth. We've been looking for an answer for millennia. Another intriguing question is whether we are the only living things in the universe. Are there aliens who wonder if they're alone in the universe? Are they attempting to contact us? Are they even paying attention to us? We've spent billions of dollars on these issues, but no definitive answers have been found. Is there an alien civilization on the horizon? Perhaps it is possible. Scientists discovered a signal coming from the direction of Proxima Centauri, our nearest neighbour star, in late 2020. BLC1 is the project's designation. Make a breakthrough, listen up. The signal is still being analysed to ensure it isn't just a reflection of our own civilization, as they usually are. But why not simply look at planets near Proxima Centauri to see if there is a civilization there? The James Webb Space Telescope has arrived. One of the main goals of the James Webb Space Telescope is to search for habitable exoplanets, where we might one day find evidence of life beyond our own planet. Using the new and powerful JWST, scientists are looking for lights that could be the final piece of evidence that an exoplanet, known as Proxima b, is inhabited by aliens. However, habitability is a sensitive issue, and discovering another Earth-like planet may be more difficult than you think. The telescope has detected carbon dioxide in the atmosphere of a planet outside the solar system for the first time. The observation of a gas giant planet orbiting a sun-like star 700 light-years away provides important information about the planet's composition and formation. The discovery, which has been accepted for publication in Nature, suggests that Webb may be able to detect and measure carbon dioxide in the thinner atmospheres of smaller rocky planets in the future. WSP-39b is a hot gas giant with a mass 1/4 that of Jupiter and a diameter 1.3 times larger. The high temperature contributes to its extreme puffiness. WSP-39b, in contrast to the cooler, more compact gas giants in our solar system, orbits very close to its star, only about 1/8 the distance between the Sun and the Mercury, completing one circuit in just over 4 Earth days. The planet was discovered in 2011, based on ground-based detections of the subtle, periodic dimming of light from its host star as the planet transited, or passed in front of it. Other telescopes, including NASA's Hubble and Spitzer space telescopes, have previously detected water vapor, sodium and potassium in the planet's atmosphere. Webb's unparalleled infrared sensitivity has now confirmed the presence of carbon dioxide on Earth. Graphs of the relative brightness of 3 different light wavelengths versus time. The top graphs forms a U-shaped valley, indicating a period of reduced brightness. The valley floor shows that the amount of dimming varies depending on the wavelength. Transiting planets, such as WSP-39b, whose orbits we observe from the side rather than from above, can provide excellent opportunities for researchers to study planetary atmospheres. During a transit, some of the starlight is completely eclipsed by the planet, while others are transmitted through the planet's atmosphere. Because different gases absorb different color combinations, researchers can use small differences in the brightness of transmitted light across a spectrum of wavelengths to determine exactly what is in an atmosphere. WSP-39b is an ideal target for transmission spectroscopy due to its inflated atmosphere and frequent transits. Webb's near-infrared spectrograph was used by the research team to observe WSP-39b, a small hill between 4.1 and 4.6 microns in the resulting spectrum of the exoplanet's atmosphere, provides the first, clear, detailed evidence for carbon dioxide ever detected in a planet outside the solar system. As soon as the data appeared on my screen, the massive carbon dioxide feature drew my attention, said Zafar Rustamkulov, a graduate student at Johns Hopkins University and member of the JWST Transiting Exoplanet Community Early Release Science team that conducted this research. It was a special moment in exoplanet science, crossing an important threshold. No observatory has ever measured such subtle differences in brightness of so many individual colors in an exoplanet transmission spectrum spanning the 3 to 5.5 micron range. Access to this part of the spectrum is critical for measuring the abundances of gases such as water, methane and carbon dioxide, which are thought to exist in a variety of exoplanets. Detecting such a clear carbon dioxide signal on WSP-39b bodes well for the detection of atmospheres on smaller, terrestrial-sized planets, said team leader Natalie Batalla of the University of California, Santa Cruz. Understanding the composition of a planet's atmosphere is important because it reveals information about the planet's origin and evolution. Carbon dioxide molecules are sensitive tracers of the story of planet formation, said Michael Line, another member of this research team from Arizona State University. We can determine how much solid versus how much gaseous material was used to form this gas giant planet by measuring this carbon dioxide feature. JWST will make this measurement for a variety of planets over the next decade, providing insight into the details of planet formation and the uniqueness of our own solar system. WSP-39b NIR spec PRISM observations are part of a larger investigation that includes observations of the planet using multiple Webb instruments, as well as observations of 2 other transiting planets. The investigation, which is part of the Early Release Science program, was created with the goal of providing the exoplanet research community with robust Webb data as soon as possible. The goal is to quickly analyze the early release science observations and develop open source tools for the science community to use, said Vivian Parmentier, an Oxford University co-investigator. This allows contributions from all over the world and ensures that the best science possible comes from the coming decades of observations. What are these mysterious artificial lights that have perplexed the best minds in the space community? And does this imply that intelligent life exists on the planet? The enigmatic light, spotted by the extremely powerful telescope in one of the photographs, could be the proof we need to conclude that another planet in the universe may contain signs of life. One of the primary goals of the James Webb Space Telescope is to find habitable exoplanets where we might one day find evidence of intelligent alien life. However, determining habitability is not an easy task, and finding another Earth-like planet may be more difficult than you think. A remarkable star system can be found about 40 light-years away. The TRAPPIST-1 system rose to prominence 5 years ago, when NASA and its partners announced the discovery of several Earth-sized planets in the habitable zone of a single star. Since then, scientists have been working feverishly to learn everything they can about these nearby planets that may be similar to Earth. When NASA scientists launched the cutting-edge James Webb Space Telescope from the Guyana Space Center on December 25, 2021, they had no idea what they were getting themselves into. Astronomers expected to find signs of life in the atmospheres of distant planets and galaxies, but they had no idea that the first images from the JWST would change the way we perceive space. James Webb is equipped with 2 infrared cameras. The first is a near-infrared camera, which can capture shorter infrared wavelengths. Second, you'll need the MIRI cam or mid-infrared instrument to see at longer infrared wavelengths. Even though the Mars planet that Elon Musk is attempting to colonize is close by, volunteers will have to travel through space for months before touching down on Mars and beginning their lives. And with that being said, it's time to end our video. Subscribe to the channel for more amazing videos like this. We'll see you with another interesting video.